It feels like everywhere you turn these days, you're just bombarded with information constantly.
Oh, yeah.
Articles and research and opinions.
It never ends.
It never ends. It's like drinking from a fire hose,
Oh,
right?
Phil. Totally.
But today's deep dive is all about how we can get well-informed faster.
Okay.
And we're going to be looking at a technique called prior knowledge elicitation.
Interesting.
Yeah, we're diving into a paper from the Bayesian Analysis Journal.
Sounds like fun.
Yeah, and this is all about translating an expert's brain
Okay.
into useful probabilities for a statistical model.
So it's like we're creating a cheat sheet for
Exactly.
understanding the world.
Yeah, and here's the thing that I thought was so interesting.
What's that?
Even experts have trouble putting their knowledge into numbers. So
Wow.
by the end of this deep dive, you're going to understand why this matters,
Huh.
what the hurdles are,
Right.
what the potential is.
Gotcha.
Could AI even help us get better at this?
Well, the implications are huge.
Yeah.
I mean, imagine if we could harness that expert knowledge in any field,
Yeah.
turn it into models that could shape decisions and accelerate research
Yeah.
and even personalize learning.
Okay, so let's start with the basics.
All right.
What exactly is prior elicitation?
So prior elicitation,
Yeah.
it's a structured process where we take an expert's knowledge
Okay.
and we try to turn it into a probability distribution.
Okay.
And then that probability distribution is used in a Bayesian model.
Okay.
And that's not the only way to specify informative priors.
Right.
You could also use data from previous studies.
Uh-huh.
You could leverage relevant research papers.
Yeah.
Or employ techniques like hierarchical modeling.
So it's like we're adding this layer of expert intuition
Yeah.
to our analysis.
Exactly.
But why isn't everyone doing this? It
Yeah.
seems like a no-brainer to me.
That's a great question. And the paper highlights 3 main reasons why this isn't being used more widely.
Okay.
They call them technical, practical, and societal reasons.
Okay.
On the technical side,
Yeah.
developing accurate and efficient methods that can be applied to any model,
Mm-hmm.
it's really tough.
Okay.
Most current methods are what we call model-specific,
Okay.
meaning they're tailored to a particular type of model.
Uh-huh.
So we need more flexible approaches.
So it's like we need tools that can work whether you're modeling financial markets
Yeah.
or the behavior of bees.
Exactly.
Yeah. Okay, I got it.
Yes.
So what about those practical challenges?
So a big practical challenge is that we lack user-friendly software
Yeah.
that integrates with existing modeling workflows.
Oh, so it's like having a fancy kitchen gadget
Exactly.
that doesn't fit with any of your cookware.
Totally. It's super frustrating.
Yeah.
And we need software that seamlessly integrates with tools like Stan and PyMC.
Okay.
So it makes it easy for analysts to incorporate this into their work.
All right, so we've got the technical hurdles, we've
Yeah.
got these software issues.
Yep.
What about the societal reasons that the paper mentioned?
The societal reasons. It boils down to this.
Okay.
We need more compelling success stories.
Oh.
Like we need to showcase the value through concrete examples.
Okay, so it's like seeing is believing.
Exactly.
Okay.
Think back to those Bayesian models that were used to understand the spread of COVID-19.
Yeah.
Imagine if they had incorporated expert knowledge from epidemiologists
Oh.
through prior elicitation.
Yeah.
The impact could have been really significant.
So we've covered the what and the why not.
Yeah.
Now let's get into how we actually do prior elicitation.
Okay.
The cable talks about a prior elicitation hypercube,
Right.
which sounds a little intimidating, to be honest.
I know, it's kind of a mouthful, isn't it?
Yeah.
But think of it as a way to visualize the different aspects of the challenge,
Okay.
like a multifaceted puzzle.
Okay.
And the paper outlines 7 key dimensions to this.
7 dimensions.
7 dimensions, yeah.
That's a lot to unpack.
It is.
So maybe let's just start with the first few.
Okay, so the first dimension focuses on the properties of the prior distribution itself.
Okay.
So are we dealing with a single parameter or multiple parameters?
Mhm.
And is the distribution from a specific family like a normal distribution, or is it more flexible?
So we're figuring out the basic building blocks
Yeah.
of our prior...
Yep.
Okay, what's the second dimension?
The second dimension is all about the model family.
Okay,
So is the elicitation method specific to a certain type of model,
gotcha.
or can it be applied more broadly?
So are we building custom tools
And-
or something more universal?
That's a great way to put it, yeah.
Okay, what about the third dimension?
The third dimension is all about the elicitation space.
Okay.
So do we ask the expert directly about the model's parameters,
Okay.
or do we ask them about observable outcomes?
Can you give me an example?
So let's say we're modeling climate change
Okay.
and its effects on sea levels.
Okay.
We can ask the expert directly about the rate of sea level rise, which would be a parameter in our model.
Right.
Alternatively, we could show them a map of coastal areas and ask about the likelihood of flooding in those regions
Okay.
over the next 50 years.
Gotcha.
So that focuses on observable outcomes
Yeah.
rather than these abstract model parameters.
So it's about how we frame the questions
Exactly.
to tap into that expert's knowledge.
That's it.
I see. Okay. So this hypercube is starting to make sense now.
Good. What's next?
Okay, so the fourth dimension
Yeah.
focuses on how we interpret the expert's input.
Okay.
Do we just try to fit a distribution to their responses?
Okay.
Or do we acknowledge that even experts have uncertainty
Oh, right.
in their own knowledge?
Yeah.
So we need to find a balance there.
So it's like we're trying to balance that trust in the expert
Yes,
with recognizing that they're not perfect.
exactly.
Right.
Then we have the fifth dimension, which is all about computation.
Okay.
Some methods are computationally expensive,
Yeah.
especially when you have complex models.
Or iterative feedback from the expert.
Yeah.
So we need efficient algorithms.
We don't want to be waiting days just for the computer to process one little tweak.
Exactly.
Right.
The sixth dimension focuses on interaction.
Okay.
Do we do a one-shot Q&A with the expert?
Okay.
Or is it more of an iterative back and forth?
Right.
And what kinds of tasks can we use to elicit their knowledge?
So deciding between a rapid-fire interview
Yeah.
and a more in-depth collaborative session.
That's a good way to put it.
Okay, makes sense.
And finally,
Yeah.
we need to consider the expert's capability.
Okay.
What's their level of statistical understanding?
Uh-uh.
What cognitive biases might they have?
Oh, right.
And all of this will affect how we design the process and how we interpret their responses.
So we're recognizing that experts are human too.
Absolutely.
Right.
With their own strengths and limitations.
Right. And by considering all 7 of these dimensions,
Yeah.
we can build a more comprehensive and effective approach
Exactly.
to prior elicitation.
That's it.
Okay, that's a lot to think about.
It is.
We've covered the what, the why not,
Yeah.
and now we've got this framework for actually tackling it. This prior elicitation hypercube.
Yeah.
Where do we go from here?
So the paper then goes on to review a vast amount of existing research,
Okay.
and they categorize it based on these 7 dimensions.
Oh, gotcha.
And this helps to identify gaps in the research
Okay.
and areas that need more work.
So it's like taking inventory of all our puzzle pieces.
Yes.
And figuring out which ones we're missing.
Exactly.
Okay.
Some areas are really well understood,
Okay.
particularly when you're eliciting single parameter priors.
Okay.
But things get much trickier when we're dealing with multiple parameters,
Right.
where we have to consider the relationships between them.
So single-piece puzzles are easy.
Yeah.
It's those multi-piece puzzles where things get interesting.
Exactly. And it gets even more complex when we move into non-parametric priors, which don't assume a specific shape for the distribution.
So those are the puzzles.
Yeah.
Well, we don't even know what the final picture is supposed to look like.
That's a great analogy.
Yeah.
There has been some progress, but we still need more efficient methods
Okay.
that can work for a wider range of models.
Right.
And this is really where research efforts should focus.
Okay. So what are some of the specific directions that the paper suggests for moving the field forward?
So one idea is to develop a unified approach
Okay.
that combines the best of all these existing methods.
Cool.
One that allows elicitation in both parameter space and observable space,
Uh-huh.
that is model agnostic
Okay.
and computationally efficient.
So it's like a universal prior elicitation toolkit.
Exactly.
Yeah.
And we also need to integrate prior elicitation into the broader Bayesian workflow.
Okay.
It shouldn't be an isolated step.
Right.
It needs to be a core part of the process.
So we want our prior elicitation to fit into our modeling process.
Yes.
Like a well-oiled machine.
Exactly.
Okay.
And they also emphasize the need for open source software
Right.
that facilitates prior elicitation and integrates with existing workflows.
Okay.
It should be user-friendly
Yeah.
and visually engaging
Right.
so that users can actually understand and validate the elicited priors.
So it needs to be both powerful,
Yeah,
but also accessible.
exactly.
Okay.
Of course, we also need to be able to evaluate these prior elicitation methods effectively.
Right. How do we do that?
This involves developing better metrics for assessing how well the elicited prior actually reflects the expert's true knowledge,
Okay.
and then how that prior impacts the model.
Right. So we're making sure our prior elicitation efforts are actually leading to better and more informative models.
Exactly.
Yeah.
And finally, they emphasize the importance of showcasing the value of prior elicitation
Okay.
through compelling examples.
Right.
We need to show the world that this is not just a theoretical concept.
Yeah.
This is a powerful tool
Yeah.
that can change how we approach problems
Yeah.
and make better decisions.
This is all really fascinating stuff.
It is.
I'm starting to see how this could be a real game changer.
Yeah.
But before we go any further,
Well,
I think we need to take a little breather.
that's a great idea. We've covered a lot of ground, and there's still more to explore.
Definitely. Okay, so we left off talking about the need for more success stories to show the value of prior elicitation.
Right. Like, how could this be used in the real world?
Yeah, exactly.
Well, one example that the paper highlights is those Bayesian models that were used to track the spread of COVID-19.
Oh, right, yeah.
Imagine if those models had incorporated expert knowledge from epidemiologists
Okay.
through prior elicitation.
Yeah.
Potentially could have led to more accurate predictions
Yeah.
and better informed policy decisions.
That's a pretty powerful example.
Yeah.
It shows the potential impact.
Yeah.
The paper also talks about developing better priors.
Yes.
What does that even mean?
So it means designing priors that are inherently easier to elicit.
Oh.
And this ties into several of those hypercube dimensions that we discussed.
Right.
Particularly the ones that are focused on making things more intuitive for the expert and
Right.
computationally efficient.
So we're basically trying to optimize the building blocks.
Exactly.
Okay, so what makes a prior easier to elicit?
The paper outlines 3 perspectives.
Okay.
First, the priors should be understandable for the expert.
Right, if they can't even grasp what's being asked,
Exactly.
then the elicited prior is not going to be very useful.
Totally.
It's one thing to have intuition,
Yeah.
it's another to quantify it.
Absolutely.
Okay, so what's the second perspective?
Second, we need computationally efficient methods,
Okay.
especially when we're dealing with complex models or iterative feedback.
Right, we don't want to be waiting around forever.
Exactly. Efficiency is key.
What about the third perspective?
The third perspective is about having fewer hyperparameters to elicit.
Okay.
Remember, hyperparameters are those things that control the shape and behavior of the prior distribution.
Right, so fewer hyperparameters means a simpler prior.
Exactly.
Which is easier to work with.
Exactly.
Right.
One way to reduce the number of hyperparameters is to use joint priors,
Okay.
where the individual priors for each parameter are linked together
Right,
through a smaller set of shared hyperparameters.
gotcha.
And hierarchical priors, which are commonly used in Bayesian modeling, are a good example of this.
Okay.
They allow us to specify a smaller set of hyperparameters that govern the overall structure.
Okay.
Now, the paper takes this idea a step further and introduces the concept of globally joint priors.
Globally joint priors.
Yeah.
What are those?
So imagine a prior that spans all the parameters in your model,
Okay.
but it's controlled by just a handful of hyperparameters.
Okay.
That's the idea behind globally joint priors.
So essentially they could simplify prior elicitation significantly
Exactly.
by reducing it to just choosing a few key hyperparameters.
That's it.
That sounds really powerful.
So here's a really interesting idea.
How do we know if these new priors are actually any good, though?
That's a great question.
The paper talks about evaluating prior elicitation.
Yeah.
What does that involve?
So evaluating prior elicitation is crucial.
Okay.
We need to make sure that we're capturing that expert knowledge accurately.
Yeah.
And that it's actually improving our models.
Right.
The paper outlines 4 key criteria for evaluation:
Okay.
validity, reliability, responsiveness, and feasibility.
Let's break those down.
Okay?
What does validity mean in this context?
So validity is about whether the elicited prior accurately reflects the expert's true knowledge.
Okay.
And this can be tricky to assess because even experts might have trouble expressing their beliefs
Right.
in precise probabilistic terms.
Okay, what about reliability?
So reliability asks, can we get consistent priors if we repeat the elicitation process?
Gotcha.
If we ask the same questions on different days,
Yeah.
will we get similar answers?
So consistency is important.
Very important.
Okay, what about responsiveness?
Responsiveness is about whether the elicitation process is sensitive to changes in the expert's beliefs.
Okay.
So if new information comes to light,
Yeah.
does the elicited prior update accordingly?
So our priors need to adapt as new knowledge emerges.
Exactly.
Yeah, that makes sense.
And then lastly, we have feasibility.
Okay.
Feasibility is all about the practicality of the elicitation process.
Right.
What are the costs involved?
Yeah.
What resources are required?
Okay.
We need methods that are efficient and can be implemented in the real world.
We need to make sure that our evaluation methods are up to the task.
Absolutely.
Okay, so the paper concludes by focusing on the need for software
Yeah.
to make prior elicitation more accessible
Right.
and integrate it into that Bayesian workflow.
Exactly.
Okay, let's talk software.
Right.
What kind of tools are needed to bring all of this together?
Well, the paper envisions open source software
Okay.
that integrates seamlelessly with existing probabilistic programming languages
Okay.
like Stan and PyMC to make it easy for analysts to incorporate prior elicitation into their work.
So making this technique accessible to a wider audience,
Exactly.
what specific features would this software need?
Well, it should support elicitation in both parameter and observable spaces
Okay.
to give users that flexibility.
Right.
It should provide a variety of different assessment tasks
Okay.
to cater to different levels of statistical understanding.
Gotcha.
And importantly, it should offer powerful visualizations
Right.
to help users understand and validate those elicited priors.
Visualizations are so helpful
They are.
for making sense of complex information.
Absolutely.
Any other key features?
I think it would be really valuable if the software could offer guidance and feedback
Okay.
throughout the process to help users avoid common pitfalls.
So like a built-in expert advisor
Exactly.
to guide you through the process.
That's a great way to put it.
We've covered a lot of ground,
We have.
from the what and the why not of prior elicitation to the hypercube framework,
Yeah.
the need for better priors, the evaluation process,
Right.
and now the software.
It's been quite a journey.
It has.
But before we wrap up,
Yeah.
the paper leaves us with 4 key takeaways to remember.
Let's hear them.
Okay, so first,
Yeah.
we need to focus on developing model-agnostic, efficient, and practical elicitation methods
Okay.
that can be applied to a wide range of problems.
All right, number 1.
Number 2, we need open-source software
Okay.
that integrates seamlessly with existing workflows.
Right.
So it's easy for analysts to use these methods.
Better methods, better software.
Yes.
What's number 3?
Number 3, we need cost-effective techniques for evaluating these methods
Okay.
in real-world settings.
So better evaluation.
Yeah.
What's the 4th takeaway?
And finally, we need to showcase the value of prior elicitation
Okay.
through compelling examples,
Right.
demonstrating the real benefits it can bring to real problems.
It's about proving the concept. This has been a really incredible deep dive.
It has.
I feel like I have a whole new appreciation for the power and potential of this.
I'm glad to hear that.
Before we go,
Yeah.
is there one big question that this paper left you pondering?
You know what really fascinates me is this.
What's that?
If we can really crack the code of prior elicitation,
Yeah.
we open up a world of possibilities.
Right.
I mean, imagine being able to translate expert knowledge in any field,
Wow.
from astrophysics to zoology
Yeah.
and to powerful models.
That's amazing.
If we can figure this out,
Yeah.
the potential is really limitless.
That's an incredible thought.
Yeah, it's pretty exciting stuff.
Yeah, it really makes you think about like the future of knowledge, right?
Oh, yeah.
And how we can take that human expertise and combine it with the power of AI.
It's a powerful combination.
Yeah, unlocking that potential is
Yeah,
it's a game changer.
absolutely could revolutionize how we approach all these complex problems, lead to all sorts of breakthroughs.
Yeah, and this deep dive has given me a whole new perspective
Right.
on the value of expert knowledge and how we can use that
Yeah,
to build these better, more informative models.
for sure.
It's like we've gotten a glimpse into the future of knowledge acquisition.
It's a future worth striving for.
Yeah.
There are still challenges, of course,
Right.
but the potential rewards are huge.
Yeah, it's been incredible exploring this topic with you.
Yeah, it's been fun.
I feel like we've only just scratched the surface,
Oh, yeah, for sure.
but I'm excited to see where this field goes.
Me too.
Well, this has been a really eye-opening deep dive into the world of prior knowledge elicitation.
It has.
For our listeners, if you're interested in learning more, be sure to check out that paper that we've been discussing.
Yeah, great paper.
And until next time, keep those brains curious.